Hello, everybody. Hello, everybody, and welcome to another live stream here with Snowflake. My name is Daniel Myers, developer advocate here at Snowflake, and today I am really excited because we have a very, very special guest. We have Brad Culberson, member of our Snowcat team, technical director here at Snowflake. Brad, how are you today?
Doing great, thanks.
Awesome, awesome. So today's topic is all around the Snowflake connector for Kafka. And so, Brad, first off, introduce yourself a little bit. Tell me a little bit about, why are you an expert in this area and kind of your background a little bit.
Sounds good. I've been at Snowflake for about 4 years now. I came into Snowflake in the field CTO office, focusing mostly around applications and help people build apps that were powered by Snowflake. More recently, I moved over to the Snowcat team, which is a customer acceleration team, helping customers build things on Snowflake and then helping the product team out on what we should be building in the future. The reason I got into this role was just a lot of experience building apps. So I was an engineer for my entire career. I worked with some pretty large companies building applications. One of the largest was for SendGrid as well as Twilio. Those were both heavily using Kafka for infrastructure, and I was an architect on those projects. So I had a lot of experience running, our organizations were running thousands of brokers in Kafka. So a lot of that expertise when I came into Snowflake, that was getting leveraged for how are these working on Snowflake? How can Snowflake connect to Kafka easier? And then how can we make building applications easier on top of Snowflake?
That's fantastic. I mean, it really shows, you have a tremendous amount of past experience before Snowflake. Being a member of the field CTO team, means you've had a tremendous amount of time directly with a lot of our customers, and now part of the customer acceleration team. That's great. So today's topic, as I said, is the Snowflake connector for Kafka. And so tell me a little bit, just why do customers use Kafka today? What is Kafka, for everybody here in the audience, and why do they use it with Snowflake?
Yeah, that's a good question. I think we don't know really the level of people in the audience, so we want to make sure we set the bar so that everybody can actually follow along today. Kafka, I think, gained popularity, I would guess, around 5 years ago, maybe a little bit longer than that, maybe less than 10 years ago. And I think a lot of systems that were created before that were synchronously coupling a lot of systems together. So you would have one system sending like data or something to another system. Now, synchronous coupling was very challenging for getting applications to scale because now both sides have to handle peak load, and also it was difficult to extend these things. So you would have a contract formed between two parties, but that didn't build a lot of flexible infrastructure. And as a lot of people started building microservices, they started building APIs. They also wanted a way to asynchronously couple systems together. And that's where this pub sub idea comes from, where you have publishers that publish information and you have a bunch of subscribers that are grabbing that information and they're doing different things. So a lot of organizations started looking at this pub sub architecture for solving a lot of different problems at scale. And the really nice thing about that is your publishers could publish data and your consumers could change over time. So as product needs change, as new services come online, a lot of new products could be developed off of the data that was already sitting there. So you don't no longer have to talk to the publisher and say, hey, please send me the data. It's already sitting there ready to be published. Kafka, I think, came to the forefront just around its scale. So it's an open source project. It's part of the Apache Foundation, and a lot of large companies. LinkedIn was one of the first contributors and contributed most of the code around Kafka. But it worked so well, and it scaled so well for massive organizations. We just saw it proliferate, and we saw tons of organizations pick it up as the de facto standard for them. And then with it being a standardization inside of organizations, when they pick Kafka, it's unlikely they're also going to plug in another technology that's similar, right? You want to have all the publishers and all those subscribers using one technology. So we often talk to an organization and they're like, oh, we use Kafka and all of our data is in Kafka today. And then the conversation with us from Snowflake is, okay, what parts of that are of interest for your data engineers, your data scientists, and your applications? How can we fit in with that ecosystem that already exists for customers?
Makes a lot of sense. So, in short, streaming is getting more common, right? Kafka is right now one of the most popular standards. It's already very scalable, and it's built to be that. there are many different implementations. And so tell me a little bit, what are some of the biggest uses of the Snowflake connector for Kafka specifically?
Yeah, I think we see the Kafka connector ourselves used a lot for like IoT type use cases. We see it a lot for security, a lot of eventing to get information from endpoints, a lot of events from systems, so a lot of telemetry events coming through, but also just data close to real time. I think we see a lot of APIs and other things where people are collecting data, maybe from click streams in marketing. So I have a lot of history there, where you have all this telemetry and information about your end users and customers flowing through your infrastructure. And then a lot of the stuff downstream of that is, okay, now how do I build data pipelines on this? How do I build a marketing application or marketing, or how do I target marketers, or allow marketers to target end users and customers in a better way with more data? And we see that in a lot. I think Kafka is very, very flexible. So we're seeing it used for almost every industry, whether that's finance, MarTech, IoT. It's pretty pervasive at this point. And a lot of it is just due to that scale and efficiency and the fact that the standardization allows companies to build product much, much easier.
So that's pretty cool to hear. So it seems like, with this connector, Snowflake really has a first class, integration with Kafka, from the ground up. Tell me a little bit more on how does this connector actually work?
Yeah, so I'll have a diagram I'll actually pull up just so we have a little bit of visual to show here. Let me get this. If you attended my talk at Summit this year, you would have seen this already, but we'll give you another shot at it today.
And so while you bring that up, tell me a little bit about, you mentioned some of the biggest, use cases that you've seen. Oh, well, it looks like we have it up. So let's
we have it. This is kind of an advanced diagram. This was meant for a fairly advanced course on this. But on the left, you see this producer, and your producer is publishing to Kafka. In the Kafka world, it's brokers, so you're publishing to brokers. The Kafka connector subscribes to those, so it's a subscriber. It runs in the Kafka Connect framework. So that's a standard framework that was also built by the Apache Foundation Kafka project to be able to allow for a flexible way to plug in things. And we have a connector that runs inside of the Kafka Connect cluster. So there's a separate cluster, but it subscribes directly to the data in Kafka. And we're running tasks inside of here that grabs data and then uploads that into Snowflake. Depending on how you have it configured, it uploads it either to an internal stage and imports it, or we also have it uploading BDEX, which is our streaming. So we'll talk a little bit about what's the difference between some of the new things that we've added. Streaming mode is very, very new, and it changes the way the Kafka connector works. And it's really just allowing us to cut the latency down more and more. And that's one of the main reasons why we focused on this last year or two, is we were seeing a lot of cases wasn't just let me connect to my Kafka on-prem. It was let me connect to my Kafka on-prem or in the cloud, and I want it in under 10 seconds. That and was something very new for us, and something we hadn't seen previously, and it's something that we had to focus on, and then change the product quite a bit to actually support.
Yeah, that's exciting to see how quickly now that latency can be reduced.
I think what we saw was like, I think people used to run these data pipelines, and it was okay to have a report that was like an hour old or like the end of the day, and that was no longer okay. So now a lot of people are running dashboards where like it's within seconds of the actual information that's coming in through Kafka. And now we're able to do that, which is really nice.
Nice. Yeah, that's pretty awesome. So tell me a little bit more about, how are you seeing customers building these data pipelines? So you mentioned just now, the need for reducing the time. What are some other ways that you're seeing customers leverage this with other things around Snowflake to build these pipelines?
Snowflake had to develop quite a few new features to make this work. I think if you look like a year ago or 2 years ago, a person building this would have used our traditional Snowflake Kafka connector in Snowpipe mode. Snowpipe usually is 30 seconds to a minute very frequently of getting data in. and they probably would have then ran a Snowflake task on a stream to then grab that data, probably normalize it, extract some fields, do some work with it, and then land it in another table. But that end-to-end time would have been probably minutes by the time you bolt those things together. And building streams and tasks, it's quite a bit of code. Like you're now, you're doing quite a bit of SQL work. You're scheduling these things. You may have multiple steps in there to basically create this, this DAG to get you to the destination. And we knew that wouldn't get the latency to where we needed it. So Snowflake worked on 2 projects. One was streaming project, which got the data in faster. We're also working on a new feature called Snowflake Dynamic Tables. You've probably heard of these. Dynamic Tables is basically Snowflake automatically materializing data for customers just based on pure SQL. And you can set the lag of that. So you can say, okay, I want this to normalize within a minute, or I want this to materialize every 5 minutes. We're working on cutting that number down. So in the future, that number will get shorter and shorter. What's really nice about that now is you can just basically create a dynamic table with SQL on this landing area where the data is coming in from, and then run all the dashboards directly off of that. So it's removing a lot of those moving parts. And we're going to get to the point where that's getting pushed down into double-digit seconds for sure.
Nice. That's going to be pretty exciting. So from here, let's dive in and see an actual demo of all this working.
Okay. Yeah, that's cool. And for the demo today, I'm going to show the streaming because that's our newest way to get data in. And I'm going to show it schematizing, which is also a new feature we have. And I'll show you why we're going to do schematization and why that's useful to you. All of this is in a quick start. So I will show you the URL to that, and you'll be able to do this later. So if you want to spend more time on this on your own, I highly suggest you do so. But it's all available online at quickstarts.snowflake.com. Let me share my screen again. There we go. That looks pretty good. So this guide, as I mentioned, it's on Quick Starts. If you search for a comprehensive guide, it's up at the top. I did a pull request yesterday to get an update to this, and so we have a more modern way of getting that with schematization. The things that are important to probably understand today, so you don't get lost during the demo, is I have this data generation tool. It's using Python. It's using Faker to fake some data. Being Snowflake, we wanted a snow theme, so I'm creating lift tickets. And all of these are just randomizing, the person, where are they from, what resort did they go to. And I have a whole list of resorts that are of interest here. And this is generating lift tickets. So I'll kind of show you what that looks like when I run it so you can get an idea of how this is working. So I'm just going to generate one record first. So there you can see this happened to be Valerie. And let's see, where did they ski at? Afton Alps. So you see I have a test generator here, Mount Brighton. So I'm going to use this to generate a bunch of data. I'm going to publish that and send it into a Kafka cluster. Today, I'm running this inside Red Panda. It's one of the easier ways to run Kafka. And you can see in here, I have multiple topics. The schematize is the one we're going to use during the demo today. So this is the topic we're going to be using. I already pre-created that. I already have a little bit of data in it, but I will also generate some more recent data during the demo and show you how quick it appears in Snowflake. And then also I pre-installed a connector. So I have a connector running right now. It's our Snowflake connector running and configured on this topic. So if you look, it's already subscribed to that schematized topic. Has my login credentials in there. And then it also has a mapping. So if you look at the connector config, you can see I'm mapping that topic name to this table. They happen to be the same name, but I map them one-to-one just to keep this super easy. So everything that I publish into the topic will automatically be read. That's JSON, as you saw in standard out. So we're using the JSON converter here to be able to take that JSON data and send it into Snowflake itself. In Snowflake, it's going to land in this table. Because I have this in streaming configuration mode, I wanted to show you a little bit of why I chose to do streaming today. So I have 2 other historical ways of getting data in Snowflake here, and I have some examples of this. Kafka batch, which would have been just our traditional Snowpipe way of getting data in. So this data was ingested a few months ago into this table using Kafka in batch mode. And you can see it uses our variant structure to have metadata in it. And then you can see the record content here is also in variant structure. and then it just has the payload of the data that would have been uploaded in batch. So this would have been delayed 30 seconds to a minute-ish, and then uploaded into variants. The second table is streaming without schematization, and you'll see it looks pretty much identical. So we have record metadata, variant, record content. The big benefit of doing it this way would have been under 10 seconds. So similar schema, but under 10 seconds into the destination, and that's using our new Snowpipe streaming mode. The one I am most excited about, and our most recent one, is the schematize. So what's very, very different about schematize is we still have record metadata that still has the variant structure in it, but we're actually managing the schema for the customer here, the end user. And you can see this actually has normalized some of this data. So emergency contact was actually a struct inside my client, so we pulled it into a variant. Purchase time was a date, so we actually added a column, purchase time, put a date in. Resort, you can see we've got this. So we've basically schematized everything, and we're managing that schema for the client entirely here. So if all of a sudden someone decides to publish a new field and that gets into the topic, our connector will automatically alter this table and add the column in and start populating the data. So it allows this to be much more flexible, and also much more easier to query. So the other one, I think a lot of people have a little negativity towards these large variant structures. This is nice and flat, and you can see here it's very, very trivial to query. If you want to say, okay, everybody that is named Kimberly, let's get a query, you could easily do a like there and pull Kimberly in if desired. So that's the table that we're going to work with today, is the schematized. I have a query here that's going to basically show me how far delayed the data is coming in, because we want to have this happening pretty quickly. So I'm going to show that. Inside of, let me go to this. What I did to set this up, if you go down and see step 13 now is Kafka with schematization. So this is how I created and registered the connector. I just specified the class. This got sent into Red Panda yesterday to get it set up properly. I have some credentials here with key pair, and then I told it to use streaming mode. And then I have the Kafka topic subscription and then the mapping. So this set up everything inside of Red Panda that you saw a few minutes ago. And now I'm going to use this publish data function or file to actually publish the data coming out of the generator. If you look at the publish, it's actually pretty basic. We're just pulling in some Kafka libraries. It creates a topic if it needs to. In this case, it was already created. The project itself is really just getting a producer and then producing. So get a producer, produce the messages coming in on standard out. So I'm just iterating across, standard in. So I'm iterating across standard in, which is output from data generator. I'm reading row by row and I'm publishing to the topic. So to run this, I can just do this. So here it's going to create 100,000 lift tickets and then send that into publish. So this will appear inside of the topic. Let me flip over and I'll show you this. So inside of here, schematized topic, messages. Let me refresh. Here you go. You can actually see data flowing in.
Yeah.
So we've got those flowing in now. Some interesting information here to look at. This lag is very important. This is how far behind the topic is. So that's 12 seconds behind. So that's how far behind the current consumer is to send data into Snowflake. This is a lot of these things are configurable inside the client. We're using default settings for everything today. And then let me show you the lag right now. So let's run this query. This just looks at current timestamp based on the max. The purchase time happens to be a timestamp now inside of Python. So I can basically say, okay, from how long from when it was generated did it show up? And here we can see it was 4 seconds. So 4 seconds from when it was created, pushed to standard out, went into the Kafka connector, and then published. It was sent to us. And here I can show you some of the recent records coming in. So here's the last record that we have coming in. And here we can see emergency contact information, purchase time a few seconds ago, the resort, everything. So it's all schematized coming in. So I think what I'm excited about really here is just that latency number. It's pretty incredible to get it in that quickly.
Yeah.
And then I could then use that data. I think one thing important when thinking about trying to cut these latencies down is try to not like move data multiple times. The one thing nice about schematize is it probably removes one step of like your downstream data engineering processes. It's probably pretty likely you could run a dashboard directly off of this table now. You could show, okay, how many tickets came in the last minute, or what was the last 10 purchases at a specific resort. Those queries could be landing directly on this landing table. And then that's going to give you basically seconds of latency between the source and destination, even without using a dynamic table, right? You can actually query the live hot data directly.
This is exciting to see. I mean, and like, seeing the how quickly this can move data around and get it into Snowflake. And so where should people go? You mentioned, this exact tutorial, is on quick starts. Where should what specific quick start should they look at? Are there others that they can check out? Where else should they go for more information?
Yep. So QuickStarts has several that I would send you to look at. First one is the one I showed today, that a comprehensive guide ingesting data in Snowflake. It's currently listed as the second one on the page because it starts with A, which is really nice. So you'll be able to find that one very quickly. That goes through all of the ways of ingesting data. So it doesn't just show Kafka in streaming mode. It also shows Kafka in the more legacy Snowpipe mode. It also shows what it looks like to just insert data using copy into or using our other language connectors. So it is a comprehensive guide. So I suggest using that. We also have one targeted directly at Amazon MSK. So we do run into, okay, what do I do if I'm running Amazon MSK and how do I get that to work? And there is a very good guide talking about that. These guides also, so a comprehensive guide happens to use Red Panda, but that same exact guide would work very well whether you're using Confluent Kafka, whether you're using Apache open source Kafka, whether you're using Microsoft Event Hubs. So Event Hubs is 100% Kafka compatible. So those same guides will work for those, and I would definitely check those out. Our documentation is very, very good. I kind of like hands-on to let me see it working. So I like the guides a bit more, but also our documentation is also very good on the connector itself. So if you go to the Kafka connector Snowflake connector for Kafka in docs, you'll be able to see a lot of the setup of how to set up different, set up schematization. You might have Kafka that does Avro or JSON. Documentation will explain how to get those to work. It works with protobuf also. So all of those things are well documented and things you can go through. What I would suggest is try to get something working locally like I did first before you jump into your organizational Kafka, because it's probably a bit easier to get a local constrained environment that you have full total control over working. And then figure out the special cases of your organization, right? Whether it's Avro or protobuf or authorization or authentication or network rules that you have to get through to make work.
Yeah.
The other thing also, there was a session last year at Summit that I did with Dimitro inside the Field CTO office around fast ingest in Snowflake. That is on YouTube. I would, if you search for fast ingest Snowflake, you'll find me and Dimitro's talk in YouTube. Suggest checking that out. And then this year at Summit, we also had a talk on advanced Kafka topics that you can find in the Summit 2024 material.
Awesome. I like that. I mean, so it sounds like there's a lot of material out there for folks that want to learn more about this. I love the advice of getting this working on locally, first. I think that's in my experience is that's key. I mean, it just kind of validates that you've kind of, you kind of know what's going on, and then apply it to what you're actually building. So from here, I want to open this up for everybody in the audience. This is a live stream. So, if you have any questions, feel free to post them in the chat, and we will be reviewing them. First one's already in, from Holloway. Can we use SQL instead of Python for getting data from Kafka?
So the quick start I showed today was using Python to do the data generation, but it does not use Python to get data from Kafka. So the connector itself should require 0 coding and 0 language. So no SQL, no Python's needed to run the connector. If data is already flowing in there, whatever teams are publishing data to your Kafka are going to be use the language of their choice. So if they were using, Python or Java or Golang or whatever languages they're going to have, they're going to be publishing to Kafka in that way. I don't know of a way of publishing data through a SQL interface to Kafka. And then the consumer itself, there's no code there. The demo today only showed code because we had to generate some fake data, which had to be in a language. And then I had to publish data because I didn't have data sitting there already to be shuttled to Snowflake.
Awesome.
Yep.
So Another question from Holloway: could we provide example how to create Snowflake Kafka connector object? You know,
The Kafka connector object, there's nothing in Snowflake that's like a connector object itself. The connector is a jar you download from Snowflake and then you host inside your infrastructure. So normally that's hosted inside of a Kafka Connect cluster. You're hosting our jar and then you're configuring it. I showed that curl request that like configured it to run inside of there. So there is some configuration. You have to authorize it and set up like which topics map to which destinations to get that working. But there's no objects in Snowflake necessary. So it's just using standard Snowflake endpoints to get data in. You will have to create a user credential there, a service credential to talk to Snowflake. I'd suggest in our examples, we usually use key pair. I would suggest you use key pair, lock those IPs down to the clients where you're expecting the data to come from in a stable environment. So that's secure.
Awesome. So while we're waiting for additional questions, I have a question for you. So talk to me a little bit about, Kinesis, Google PubSub support.
Yeah, so we get a lot of questions around this because some orgs haven't already adopted Kafka. If you've already adopted Kafka, it's really easy. You run the Kafka connector. I would not say your org should adopt Kafka if you're not using Kafka today just to get data to Snowflake. Kafka is a fairly large lift. It's a fairly complex technology. I think it's a great technology, but if you're already using one of the other alternatives, so if you are using Kinesis or PubSub, there would be no reason for you to run Kafka in parallel to that. Like as I mentioned earlier, organizations should probably standardize on one of these. Running multiple is probably not going to be fun for any of the engineering teams that are working on this. So what do we do with Kinesis? I think luckily Amazon has built a connector for Kinesis that uses our streaming SDK. So the Snowpipe streaming that I talked about during this, we rewrote over the last few years to use we have an SDK that's written in Java that allows it to power this, close to real-time streaming use case. And Amazon took that same SDK that we had built, and they built a Firehose. They used to call it Firehose. I think they've rebranded some of their Kinesis stuff now. But they now have basic connector that will go from Kinesis to Snowflake using streaming. That's supported by Amazon and runs out of the box and is quite good from what I've heard. So I'd suggest you check that out first. No code, it's configuration based and it just works, which is nice. What people did before that is they would run something like Kinesis Firehose to S3, and then they'd run our Snowpipe to ingest. That works quite well. It actually scales really, really well to massive data, but you get more lag there because it's not using the more modern streaming technology there. You're gonna have more lag of, how much data needs to be aggregated before it drops the large file in, through Firehose, and then us picking that up through our serverless infrastructure to import it. So there's multiple options there for Kinesis. I've had a few customers roll their own also using the SDK. That's a lot more code. I would only suggest that for very advanced customers that have tried using the other two options and those aren't working, because those are like no code solutions. PubSub's a little bit harder because we don't have our own connector for this and Google hasn't built one. So we don't have either story for PubSub right now. So what we're telling customers today is to look at building it using the Java SDK if you want something close to real time. So far, I haven't seen a customer build that, mostly because we have a very few number of Google customers using, as well as a few number using PubSub mixed with Google. A lot of people are still hosting Kafka inside of GCP, and we're seeing that as like the most common use case. If you want us to prioritize that higher, reach out to your account teams. Like we're always listening to customer feedback and prioritizing projects based on number of customers. The more PubSub gets adoption and the more Google customers come in, the more likely it will be that we prioritize them.
Nice. So we got another, actually two questions. John Farr. So question on the new schematization feature. One, does this work with JSON that contains multiple nested arrays? And two, what happens if the data type changes inside of an attribute's values, such as strings and arrays?
Very good questions. It does work with nested arrays and nested objects. That'll show up as basically a variant structure inside of Snowflake as the top level, and that can contain any depth of object hierarchy or array hierarchy. It's a very flexible data type in Snowflake. We also collect columnar statistics on all of those, so you'll actually see things like pruning happening on those variant structures, which is really nice. So there's not a large performance impact for those variant structures. When I talk about schematization, you're getting a benefit there because it's easier to query. but also like you could still leverage variance. We see that a lot where it's like, okay, here's the primary fields that are of use at the top level. And then there's a payload of a bunch of like other attributes that are just more flexible that land around. So that actually happens quite a lot where we have a mixture of schematization with still variant structures. Data type changes is a challenge that is going to be very difficult for you to operate in production. Right now, you will break a pipeline if you change a data type that's incompatible during runtime. So this will break in production. It's something we have a feature inside the connector called dead letter queue. I would probably enable dead letter queue. That will start throwing messages in a dead letter queue if you get data type changes. That would be something like what used to be a string in the payload turned into a number on the same name inside the structure. So it's something to watch for. If you think, most times we see customers hit this is when they have multiple teams all publishing to like the same topic, because then you have no coordination. Two people just happen to pick the same name for some field, right? Like they may call it like the event date. One person might have that as a string that's like a RFC date. Someone else might have that as a Unix date time as a numeric or something. So that's normally where we'll see it happen. It's something to be thoughtful of during your design to make sure that that will not happen in the future, because that will be very painful when it does happen and it will break the pipeline.
Makes sense. Makes sense.
Yep.
Now,
so another alternative to do there too, if you are trying to fix that in a production system, Kafka Connect does have some really nice tooling for like, I'd say doing a minor transformation while it's actually processing it. So you can do a minor transform directly in Connect, where you could, like, based on event type or something else, like rename some fields there to make sure they don't collide. But I wouldn't do that unless like it was a massive engineering effort to like get those things separated out from each other.
okay, yeah, that's good advice. So another question has come in so first, can Snowpipe streaming or Snowpipe streams replace Kafka, or is it limited to consuming data from a Kafka connection and primarily works within the Snowflake ecosystem? And then two, for a real-time pipeline requiring millisecond level latency, would inserting data into Snowflake be slower compared to using a full end-to-end Kafka pipeline?
That's good questions. I think Snowpipe streams do look a bit like a pub sub system, because you can have like multiple streams attached which look like different consumers that can fetch data off the table. We don't see it commonly being used by customers in this way, where they're like using a Snowflake table as a pub sub mechanism, even though it could. That's a very interesting use case. I think what we normally see is they've already adopted the pipeline, but I would say they overlap incredibly, because if you register a stream that looks a lot like a Kafka consumer, each has their own sets of offsets and they can all read data. Like one thing that's a little bit different is in Snowpipe streams, like we'll merge multiple like updates together, and like you see the difference between the last time you queried the table. You don't see every incremental change that actually happened between the last and the current, and that's a bit different. Where Kafka, you have a guaranteed in order list of all the things that happened between 2 points in time. So they are operating a little bit differently, but they overlap enough there where I could see some use cases actually work on streams without having Kafka. The millisecond latency, I think that's very challenging. I think what I showed today, we have seconds of delay between the client getting into Snowflake. Single digit seconds is quite attainable with the right configuration. The more data that flows here, the actually easier it is to tune these systems up. So when we talk to customers that are pushing like, hundreds of megabytes a second or something, it's actually a best case scenario, because now we can get large data flows writing large packages of data and ingest that into our metadata layer quite well. Millisecond latency end to end is something that I don't think is solvable with neither the Kafka connector or Snowflake inserts. If you do performance on Snowflake inserts today, best case scenario on a traditional table, you're going to be into many hundreds of milliseconds. If you start running concurrency on that, it's going to be much, much worse, because a lot of those will turn into serialized inserts or updates. So they're going to be locking and continuing with each other. If you have a use case with a high amount of concurrency with inserts, or Unistore and hybrid tables are kind of the targeted use case there. And then we're still targeting 50 to 100 milliseconds there for like those insert rates. But I would think through that use case a little bit and try to figure out, but an insert into a hybrid could get data available in Snowflake faster than what the than the Kafka and Snowflake connector would give. It would not give you the same throughput. So the examples we showed today, I've literally, during our demo at Snowflake this year, we pushed 800 megabytes a second through it. Trivially, during the demo, you could not push 800 megabytes per second into a hybrid table with any success whatsoever. That would be millions and millions of records per second, which is not attainable on any OLTP style table.
Gotcha.
So
Yeah.
I think what we see is these use cases. I think Kafka is normally used for like large data flows, or where this batching and seconds is good enough.
Well, that is some great insights. And as many of the audience have already said, this has been very insightful into the Snowflake connector for Kafka. And so, Brad, I want to say a big thank you for joining me here today to learn all about this. As a last call out for everybody watching, you can get hands-on with the exact demo that Brad was showing today on quickstarts.snowflake.com. Also, check out the documentation for the Kafka connector, Snowflake's connector for Kafka, in our docs.snowflake.com. And also check out some of the videos that Brad mentioned on our YouTube channel. This is Snowflake Developers YouTube channel. So with that, thank you everybody for joining. Signing off, I'm Daniel Myers.